Welcome to the second video on light. So far, we have looked at electromagnetic spectrum and refraction. In this video, we're going to take a look at refraction, and then in the next video, we'll look at lenses. Let's get started. So, to understand refraction of light, we're going to use this picture. Remember, light travels in a straight line. There are only two ways in which that behavior can be changed, and that is when it bounces off a surface through reflection, or when it changes its direction as it passes from one medium to another. So light changes direction as it passes from one medium to another, and that property of light is called refraction. So imagine we have two medium here. So there is a boundary. This side can be, for example, air, and the other side can be, for example, water. So this is the boundary of air and water. So if a ray is coming like this, this ray, of course, it's going to be the incident ray, and the angle between the incident ray and the normal is called angle of incidence, as before. So when it hits here, the boundary, it's going to change its direction. We expect it to continue like this if it's moving in a straight line, but it's going to bend. It's going to change direction like this. So this ray, which comes from the boundary, is called the refracted ray. And the angle between the normal and the refracted ray is the angle of refraction. So the angle of refraction is also represented by R, just like the angle of refraction. Remember, the angle of refraction in the previous video we are using R, so even refraction is the same. So refraction is due to the different speeds of light as it travels from one medium to another. When light travels from less dense to denser medium, light is refracted towards the normal. So if we have two medium which have the same density, then light cannot be refracted. What causes light to be refracted, to bend, is because of the different densities. So we have three situations. First situation is where the light is coming from, it's less dense and it's going to a denser medium. In such a situation, we have this scenario here. So in this scenario, the light ray is going to be bent towards the normal. If this is less dense and this is denser, then the ray is going to be bent towards the normal. It's going to be refracted towards the normal. That's the behavior. What about when it's opposite? When it's coming from a denser to a less dense. So when light travels from a denser to a less dense medium, light is refracted away from the normal. So we have this situation. A ray is coming. I forgot to show the direction of a ray. A ray should always have a direction. So when it hits the normal here, it is refracted away from the normal. So how do you tell if it is away or if it is towards the normal? You first assume that this ray is supposed to continue straight like this, but because of the medium, it's going to bend, and so this is used as a standard of comparison as to whether it is away or towards the normal. So in this case, since the ray is this direction, it is away from the normal. So that this is what happens when light moves from a denser medium to a less dense medium. Then the third scenario is when light enters another medium at right angle to the boundary. In this case, nothing happens in terms of direction. Light is not bent. So if a ray comes like this at 90 degrees, it will continue like this, despite these having different densities. This is the behavior that has been observed. Next, we take a look at laws of refraction. So the first law is the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant. So what is sine? You understand this in just a second. So the constant number is called the refractive index, and this is called Snell's law. So mathematically, Snell's law is expressed like this: n is equal to sine incidence over sine refracted. Okay, so sine angle of incidence over sine angle of refracted. What does sine mean? Sine is a mathematical function which you can punch on a calculator. So when you say when you want to find sine incidence, you have to get the angle of incidence. Let's say it's 45 degrees. So you say sine, you are going to punch sine on the calculator and 45. Then you do equals, it will give you the number, whatever number is going to give you. That's the answer to sine incidence. So sine incidence over sine refracted is always constant for two given medium. For example, the refractive index of air and water is always the same. This is the first law. The second law is just like the second law of diffraction, which talks about the incident ray, the refracted, not reflected, it's an error, it's supposed to be the refracted ray, and the normal are always in the same plane. So to appreciate Snell's law, let's tackle this question. Find the refractive index in the diagram below. So we have the angle of incidence, which is at 50 degrees, and then we've got this this angle here. So here you can be convinced that this is the angle of refraction, but it's not, because the angle of refraction is the angle between the refracted ray and the normal. So here it's always 90 degrees. So to find this, you have to do 90 degrees minus 65. Sometimes it is given direct, sometimes it's not. They'll give you this, so that for you to find this, you do 90 minus 65. So that's the angle of refraction here. So the data from the diagram is of incidence 50, refracted angle is 90 minus 65, which is 25, and we're looking for the refractive index. So we're going to deploy our formula: sine incidence over sine refracted. Sine incidence is 50, sine refracted is 25. So we're going to get 1.813 when you punch this on a calculator. It is a ratio, it has no units. This is the refractive index. Next, we're going to take a look at what is called a critical angle. So this is the last part of this video. So what is a critical angle? A critical angle is the particular angle of incidence of a ray hitting a less dense medium, which results in it being refracted at 90 degrees to the normal. So a critical angle is always talked about when we have a denser medium and a less dense medium. Then a ray should be coming from a denser medium and should hit a less dense medium. And when that happens, the ray to be refracted should be refracted at 90 degrees to the norm. That's a critical angle. So there are three situations when we're analyzing critical angle, where we compare the angle of incidence and the angle and the critical angle. So what we're trying to achieve in this is there's always a critical angle. So depending on the behavior of the ray when it is refracted, we can tell that this angle I've used for incidence is greater, less, or equal to the critical angle. If it is equal, then it is the critical angle. But if it is less or greater, then it is not. So to tell if it is less, greater, or equal to the critical angle, these are the observations that can guide you. So in the first situation, we're going to start with this diagram. So in this diagram, what I've done here, I've drawn the rays in a different way. We are used to a ray coming from here, so sometimes they can draw them upside down, like a ray is coming from here. Since you're not following the arrows which shows the direction of rays, you might end up thinking that the ray is coming from here and being refracted here. In short, you might think this is the angle of incidence and this is the angle of refraction, when in truth this is the angle of incidence and this is the angle of refraction, because the ray is coming from here and it's being refracted here. So in this situation, when ray comes here and there is an angle of refraction which is less than 90 degrees, then in this case the incident ray here is at an angle which is less than the critical angle. The critical angle should give you 90 degrees. So what happens is, if you keep on increasing the angle of incidence, the angle of refraction will be increasing here. So the fact that the angle of refraction is less than 90 degrees, 90 degrees is from the normal to here. So this angle of refraction is less than 90 degrees, means that the angle of incidence you have used is also less than 90 degrees. Therefore, the angle of incidence is less than the critical angle. The critical angle is a particular angle which we don't know, that will give us 90 degrees here. Then the second situation is where this incidence gives you this refracted ray. So in this case, this refracted ray is 90 degrees, mean that this angle of the incident is actually the angle we are looking for, which is the critical angle. The other one is where as you are increasing the angle of incidence, then we don't have any angle refraction and we have some reflection. Such a case, it means the angle of incidence is greater than the critical angle, and this kind of reflection is called total internal reflection. Total internal reflection. So this marks the end of part 2, not part 1, sorry. This marks the end of part 2. Hope you have enjoyed. Happy solving.